welcome. Just a quick notice, we are recording this, so for future use. Thanks everyone for being here. My name is Kathy Hoverman, and I'll be moderating today's webinar from the Joint Committee on Fisheries Engineering and Science. It's a collaboration of ASCE's Environment and Water Resources Institute and AFS's Bioengineering section. I'm glad you found us today. I apologize for the change up in the link to get access to this. If you hear of somebody who wasn't able to join us because they got stuck on the old link, remind them that this will be recorded and available through YouTube. I'll provide that YouTube channel number is just below here. You can also find more information on the Joint Committee at the QR code or the web address shown on this. This is our 4th webinar of the year. We provide quarterly webinars and have been doing so since 2015 to share information on aquatic organism passage, dam removal, fisheries improvement, community and stakeholder engagement related topics. You can also connect with us on LinkedIn and follow some other updates that we might have there. A few resources we just want to call out. There are several really great kind of learning tools and implementation knowledge under the dam removal training resources, also found through our webpage. Fish Passage 2026 will be May 4th through the 8th at the University of California, Davis, which is strategically placed between Sacramento and San Francisco. The theme of the conference is Headwaters to Sidewaters to Estuaries, Improving Watershed Connectivity and Processes through Restoration, Revitalization, Remediation, and Reintroduction. The organizing committee is still working out some of the details for the conference, but it's going to be epic, and I hope to see you all there. Early May will be a great time to be in the Central Valley of California. Weather is sunny and warm, usually. And there's plenty to see and do around the area. So hopefully you will be able to join the conference, come out on some of the tours, also enjoy the workshops, and just have a great time connecting and learning at the conference. Associated with the conference, there are 2 awards, the Career Achievement Award and the Distinguished Project Award. Both of those are open for nominations until January 16th. So given that we have started the holiday season, January 16th comes really fast. So if you've got a project that has some amazing fish passage results, do please nominate it, your project or someone else's project, for the award. And similarly, if you know someone who's had just a really great impact on your career or others, nominate them for the Career Achievement Award. Our next webinar is scheduled for February 10th, 2026. It will have the correct link in it immediately upon posting. Will be with Dale Higgins, formerly from U.S. Forest Service, talking about his recently published work on designing flood-resilient road stream crossings. It's based on case studies done in the Chequamegon-Nicolet National Forest in Wisconsin. For today, we have the Mud Mountain Fish Passage. Our speakers are Casey Butcher, the Mud Mountain Dam Fish Passage Facility Operations and Maintenance Supervisor. He's been with the U.S. Army Corps of Engineers for 10 years and has worked on the Fish Passage facility through construction and commissioning. Also, Nate Malmborg holds a degree in Fisheries and Aquatic Sciences from Utah State University and has been serving as a biologist with the U.S. Army Corps of Engineers since 2017. In his role, he contributes to environmental stewardship and natural resources initiatives at Howard Hansen Dam, Mud Mountain Dam, and the Fish Passage Facility. Outside of his professional responsibilities, Nate is an avid fly fisher and enjoys kayaking in the Puget Sound whenever possible. I like those hobbies, Nate. Sounds good to me. With that, I'm going to hand it over to Nate and Casey, and I hope everyone enjoys the show. Thanks, guys.
All right. Well, thank you for that introduction, Kathy. I really do appreciate it. Well, hello, everybody. Good afternoon. I'm really excited to be here, talk about our new fish passage facility with you. So let's see, get this shared. Hmm. And swap. There we go. I think we can all see the correct screen here. All right.
Yep, looks
So,
good.
all right. Yeah, a little bit of background here. So, here in Washington, on the White River, is a Mud Mountain Dam. It was constructed and completed in 1949. It is an earthen dam, and it's usually operated as a run-of-the-river dam, which means we usually don't have a pull unless we're holding back a flood. Um, you can kind of see, let's see if I can figure out this pointer. Yes, I can. You can see the dam back here, a little switchback road that goes up. There's the original dam intake structures and our current trash rack and intake with the pedestrian bridge up there. And of course, this is in the forebay looking downstream. And yeah, a few really neat historic photos. We recently brought on a couple of volunteers here at the dam, and they're digitizing a lot of these. I mean, it's a huge stack of binders of old photos. It's been really fascinating to see what they've been able to dig up. But there in the middle, you can see the 23-foot tunnel which runs through the dam and the construction of the spillway there. Pretty fascinating. So the White River, it is a tributary to the Puyallup, and the Puyallup, of course, drains into the Puget Sound. You can see here, and you'll see later, actually, the river actually does run white because it's a glacial river. Um, this is Emmons Glacier. It happens to be the largest glacier in the lower 48. Um, yeah, so it's exciting stuff. I am going to turn off my camera. There we go. So here on the White River, we do have three listed ESA species. We have the Puget Sound Chinook there on the left. We have the Puget Sound Steelhead there in the middle, and of course the bull trout. Um, Even though there seems to be kind of an upward trend for both Chinook and Steelhead returns, um, if we're looking at all of the historic data. Unfortunately, just looking at the past 10 to 15 years, it does kind of show a declining trend. Um, Bull trout, on the other hand, they have stayed pretty consistent in their numbers. Their trend remains fairly level. Um, Definitely not a large population here on the White River, but they're definitely here. And yeah, here's kind of a graph showing what I was talking about in that last slide. Um, Overall increase in returns, but a slight decrease in more recent years. Um, yeah, and gosh, just looking at all of this historic data going back 86 years, that's pretty incredible. Um, but yeah, we have the coho there in gray. They're not ESA listed on the White River, but we do track them. And we have the Chinook there in black. And steelhead also, like bull trout, kind of have always returned in low numbers. Okay, so a little bit more history. Back in 1910, Puget Sound Energy, they constructed a barrier dam and a fish ladder in Buckley. It's a town just downstream of Mud Mountain Dam. Um, they built this barrier so that they could divert water from the White River to fill lake taps, and that water would be used to generate power at a powerhouse, which was decommissioned back in 2004. Um, then what happened in 1941 is the existing fish ladder that was there was converted to a fish trap, a trap and haul facility, which allowed for fish passage past the barrier dam and Mud Mountain Dam. And yeah, that was a trap and haul operation. Interestingly, the Buckley fish trap was one of the first of its kind. I guess that's kind of why they named that type of trap the Buckley style trap. Um, so they designed it in a way that they could capture adult fish for sorting and sampling. Uh, and what was really unique about this type of trap is it had a floor that would raise, and it would help facilitate our tribal partners for sorting fish and sampling and taking brood stock and whatnot. Um, you can see in the photo here, that's that braille floor that I was talking about that raises, and biologists in there netting. And really, gosh, watching all of that work in action, it was a lot of work. Um, you know, trying to net the fish that you wanted, handing a net full of fish up to the next biologist up high, and then and sorting them and processing them from there. Um, yeah, so not an ideal setup for sorting fish for our tribal partners, but there are always safety concerns. The braille system could be a bit stressful for fish with, the excessive handling and whatnot. A little bit bittersweet, but the old trap was demolished this year as part of our phase 3 for the fish passage facility project. Yeah, a lot of history there, and it just looks a little strange there on the other side of the river without the old trap. So, all right, so here we can see, yeah, there's the trap on riverbank left. Here's the old barrier, the Buckley barrier that I mentioned was constructed. And here you can kind of see the concrete apron that barrier, the flashboards would sit on. Yeah, it was constructed with timber and crib, and every year it would breach during a flood. So they'd have to go in and repair it every year. They'd have to go in the river, build a cofferdam, um, replace all the flashboards. It was really quite a process. Um, yeah, and in more recent years when it did exist, it wasn't very fish friendly. It caused a lot of injuries and mortality to our ESA listed species. And just the trap itself, it couldn't move fish fast enough to make room for our ESA listed species. So this is kind of what happened. If you're not familiar with the area, pink salmon haven't always, been here in a lot of our Puget Sound rivers. In 2003 is when we first saw pink salmon in the White River, and it did become pretty obvious that our trap and haul system at the time was pretty much being overwhelmed by the huge masses of fish. And yeah, unfortunately, the numbers of pink salmon returning resulted in a delay in transporting our Chinook steelhead and bull trout. And that was even after purchasing more trucks, bumping up crews to 24-hour hauling operations. They just couldn't keep up. Um, so yeah, this is kind of a graph just showing overall Puget Sound pink returns in comparison to the Fraser River, which has a massive pink run. And here on the White River, um, yeah, we get pink salmon in odd years. So you see the spike here, spike here, spike here, and then look what happens. 2000, 2023, it was just a massive return. Um, 1.4 million fish is what we transported that year. So yeah, before that, in 2009, um, a million pink salmon showed up to the trap, and the Corps of Engineers, we were only able to transport half of what showed up. So it was pretty obvious that at that point something needed to change. So in 2014, NOAA Fisheries issued the Corps of Engineers a biological opinion for our ESA listed species. The design criteria included, the design criteria included building a facility that can attract at least 95% of the fish that showed up, and with a 98% survival to release. It needed to have a capacity to be able to move 1.25 million fish annually. And that, if you could imagine, is a nightmare for logistics. If you look at the time frame for when that 98% of those fish arrive at the facility. 60,000 fish daily transport. The facility shouldn't delay ESA fish for more than 24 hours. And the facility should be designed to operate from 360 to 3,600 CFS. And also the Corps would be required to construct a research, monitoring, and evaluation facility. And we call it the RMNE. All right. So yeah, to meet our new buyout requirements, the Corps designed and contracted the construction of a new fish passage facility. We've got a couple of BIM drawings of the 100% design showing some of the main components of the entire facility here. In a nutshell, I guess the fish passage facility consists of a barrier, 3 Obermeyer gates, a Tainer gate, and that Tainer gate is used to manage sediment. We have 5 fish entrance gates here. There's 4 along this flat wall and an angled gate here used for high flow fish attraction. That leads into the fishway here. And then we have a fish ladder with 10 pools. And those pools are delineated by ice harbor style weirs, which I'm really a fan of because it allows for fish to either pass above or through the weir, depending on species preference. They're pretty great. Also in the ladder, we do have 3 pit antenna arrays. So after the ladder, it leads into 2 pre-sort pools. Each pre-sort pool has its own crowder, and they gently guide the fish up to 2 Archimedes screw lifts. These things are massive. They're 55 feet long. Yeah, it's really pretty incredible. I do have some footage I'll share here shortly. So yeah, once the crowder is fully positioned forward, we do have the capability to raise a foot crowder for any scragglers, for any fish that need a little bit of, an extra push to go up the ASL. Yeah, and at the top of the ASL, we have a couple of workstations where we have folks counting, IDing fish, and directing fish where they need to go. And yeah, and then this drawing here is kind of more depicting the facility with more of a focus on the sorting, monitoring, and hauling aspects. But yeah, as you can tell, I mean, there is a lot to this facility. And yeah, this is basically what the facility pretty much looks like today. I guess with the exception of the parking lot is asphalt now. The channel certainly looks a lot more different now. I guess that is one of the good things about these Obermeyer gates, is it does give us the capability to shape the river for optimal fish attraction. We can shape the thowag to get it a little bit closer to the entrance gates here. But yeah, that being said, our first fish was passed in December of 2020, but regular operation of the facility didn't start until July of 2021. And, just kind of due to how complex our operations are and how many moving parts there are in the facility, I figured that sharing a couple of videos might be really helpful. I guess it's kind of the next best thing to actually being there in person. So let's hopefully this will work. I will try this out. Probably got to get off this pointer. Of course.
Nate, while we're watching this, there was a quick question that came in that said, where on the White River is the facility located? Can you give a verbal description of that
Sure thing.
while we're watching the
Yeah.
video?
So it is about 5 miles downstream of Mud Mountain Dam in a town called Buckley. Well, Buckley is the other side of the river, so the new fish passage facility is actually in Enumclaw, Washington. Um, it is in King County, same county as Seattle. All right. Well, I'm really hoping that audio was playing there. I didn't think to ask. Did you hear anything there, Kathy?
No, it wasn't on.
Oh, shoot. Oh, my apologies. I don't know. Golly. Well, for this next video, I've heard some complaints about the music. There's actually no audio. But yeah, if you are interested in watching that video, it is on YouTube. All you'd have to do is look up Mud Mountain Dam Fish Passage Facility, and it is the one that is has the core logo on it. Yeah, terribly sorry about that. I don't know why it didn't go through. Um, all right, so yeah, this next one here, and I'll kind of fiddle with the audio settings here to see if I can control that. Let's see.
No
So
sound on my end so far. Yours
okay,
must
so
be.
this is all just going to be text and some very repetitive music in the background. It's a really excellent video. I'm very thankful for our summer intern who had a lot of videography experience she had put together for us. Um, Shout out to Cecilia, Green River College. So right here, you can see pink salmon. Unlike a lot of the other species, this species tends to volitionally enter the ASL. They'll just scream up there, no crowding necessary. Um, but we do still have to crowd every day just to, urge other species to make it up and through the ASL so we don't end up with just all pink salmon. But yeah, just looking at this video too is making me think, gosh, we really have done quite a bit of work to improve the facility. Um, I know Casey's gonna share some of this here when he's up, but um, yeah, a lot of this looks quite different. The drains there at the top of the ASL we found were injuring, um, tearing fins and causing some minor descaling on some fish. So Casey and crew ended up patching up that drain at the top of the ASL. So it's nice and smooth now. Yeah, designed to move 60,000 fish a day. And just this last pink run this year, Crew came very close. I think this video says that our record day was 53,000 fish. But this year, they broke that record with 56,000 fish. And yeah, that is a lot of fish, a lot of trucks. And while all of these trucking operations are happening, we have, everybody with their own responsibilities. Somebody on the hoist to lower um, the flume onto the top of the truck. They'll also be monitoring oxygen levels to make sure that oxygen's good, temperatures are all right. They're monitoring to make sure the truck, if it's slow fishing, that the truck isn't there too long. If they hit a certain time, then they'll send the truck on, even if it's not full. And yes, even though we did have the record day haul this year, we didn't quite meet the 1.4 million. We were just shy at just over 900,000. That's still a lot of fish. And yeah, I'm told that, I mean, this year they were seeing pink salmon all the way up green water and beyond. They are highly motivated to get up there to spawn. It's pretty incredible. And I do apologize again about the audio, but like I said, that last video was just some background music there. Hmm. Okay, there we go. All right. So yeah, so now we have our NIMS criteria for needing to track 95% of the ESA fish that get to the facility, right? It has been kind of a learning curve for the past few years. We've been trying to figure out how to best get the fish to enter the facility, so that they can get through as quickly as possible, safely. In this video, you can kind of see, just the typical pink salmon behavior. They're stacking up along the wall here, getting ready to move into the entrance gates. And across the river, it'll zoom in here. You'll see a school of pink salmon kind of milling around. They're not entering the facility. So at this point, what Casey and crew would do is they'd manipulate the entrance gates to shoot a jet of attraction flow in that direction. So it's always good that they're keeping an eye out, seeing what's going on out in the river. But yeah, they'll shoot that jet in that direction, or they'd adjust the Obermeyer gates to reshape that bow lag in the river. But yeah, we have ongoing studies contracted through PNN now and Portland District Fenton Con, where they radio tag Chinook salmon and they track, whether or not they're entering the facility, or whether they're staying or being retained in the facility, and if they're navigating through it in a timely manner. We don't want to exceed that 24 hours holding. Yeah, we already saw the pre-sort pools in that video, but yeah, just here a quick note. You can see the feed traps. I was mentioning retention. Those attraction studies that PNNL conducted did show fish kind of moving in and out of the pre-sore pools. Um, so since then, the V-traps, have been taken out as of now, and we'll likely see what those are now replaced with. Um, And yeah, we did already see the crowding operations also. You can operate the crowders either on the crowder itself or by the control panel at the top of the ASL. Um, this clip seems to be broken, but it's just kind of like what we saw in the video though earlier. It's just pink salmon volitionally entering um, the ASL. And yeah, counting, identifying, and sorting. This is at the top of the ASL here. And counting is not an easy task. When you have several species of fish that are moving through, you're trying to direct fish to either the trucks or the research holding tank. It can get pretty tricky. Um, this gentleman here, Evan, in this video, he probably counted and identified, around 500,000 fish in 2023. I can even imagine 20 plus fish each rotation of the ASL, for 12-hour days, 6 day weeks. It's pretty daunting to think about, actually. And there's Paul, the gentleman who counted the other 500,000. All right. Yeah, I really do love this photo here. It's the original fish trucks from the 1940s. I mean, it kind of goes to show, like how far we've come, but still using the very same methodologies for moving fish. Interesting. So yeah, currently we have the 5 tanker trailers. They're 5,200 gallons. That's a 5,000 gallon tank with a 200 gallon flush. And we have 4 small trucks, each 1,200 gallons. And there's our upstream release. We saw that in the video. Um, I guess I can play this one, show a little bit more detail on the release process. Um, so you'll notice they open the small hatch at the end of the truck here. Um, they do this to drain some of the water before fully opening it to release the fish. That'd help reduce velocities so you don't end up with fish all over the deck. Um, and having to wait so long to drain half the water, that used to be kind of like an operational burden or a pinch point. Thankfully, we don't have to do that anymore because our new tankers are retrofitted with baffles that were installed, and those actually greatly reduce those release velocities and wait times too for the trucks, so they can head right back to the facility for the next load. Um, what else? Here's kind of a neat video. Yeah, so nothing like a slow-mo video to add some dramatic effect. Well, one of my fun tasks that I get to do is monitor the release site for fish safety. I'll wait out there during low flows whenever the river 500 CFS or below, and I'll just make sure that the site depth is sufficient for fish. Because we put all this effort into attracting fish, safely trapping them, hauling them um, upstream. It'd be all for nothing if we were just to release those fish into water that's only a foot deep. Thankfully, it hasn't gotten that shallow yet, but if I do find that depths aren't sufficient, I'll let Casey know. And we found that just running a truck full of just water through the flume That works great. It's more than sufficient to kind of clear out the way for the next truck for fish to be safely released. Yeah, and since the FPF came online and operational, we have greatly reduced mortalities and injuries in the facility. Um, you know, we report our mortalities to NIMS. We track all of these things. We track injuries, significant injuries would count against our take per our biological opinion. Um, we'll monitor injuries, work closely with our tribal partners as they're sampling fish, um, and yeah, we'll report all of that to NOAA Fisheries. Fish attraction efficiency, it's getting there. Really hopeful that what the crew implemented this year will show that we are meeting or exceeding our requirement. And yeah, so on a daily basis, we do try to, to the best of our ability, we try to track environmental factors to see if there are any correlations to these environmental factors with fish movement into the facility. Just knowing when fish move can help prepare for staffing, potential weekend work. We track everything from water temperature, air temperature, head differential, ENT gate openings, barometric pressure, dissolved oxygen, you name it. It's we're tracking it. Yeah. And yeah, so operational challenges, I can say one of the most challenging things at the FPF that we have to deal with is all of the highly erosive glacial sediment that blasts down the river. This sediment really tends to get into every nook and cranny of the facility. It wears all the pumps, it clogs the intake screens, it erodes concrete. It's really pretty eye-opening to see the erosion is already happening after only a few years of operation. But yeah, Casey has come up with some pretty ingenious ways to deal with sediment in the facility, and I'm hopeful that he'll cover some of that in a bit if I don't take all this time. Holy smokes, I better move it. But yeah, you can see, I mean, this sediment, this is in the pre-sort pool. Currently, there's probably about 3 times more than this amount of sediment in the pre-sort pools, and that doesn't make for easy crowding. If you want to get a clean, full crowd of the pool, not easy to do with lumps of giant sediment in it. All right, so yeah, here's my contact information, everybody. If any of you want to get with me offline or reach out, please feel free to do so. And yeah, now that you have a general sense for our mission here at the FPF and how we operate, I would be happy to pass the mic on to Casey.
And it looks like Kevin is answering a lot of your questions in the chat. So
Great.
while we get Casey going, if Kevin, thanks for addressing some of those questions. I think we're probably going to be pretty short on time when Casey's done. So please continue to do so. Keep adding questions, and Casey, we're looking forward to what you have to say too. Thanks.
All right. Good afternoon or morning or evening for all of you. So I'm going to go over kind of how the flow goes through the facility. As you saw these, everybody see this okay?
Yeah, you're good.
Okay, perfect. So these are the intake gates. They're above the barrier. So the barrier provides about 3 purposes. It supplies the water supply for our facility. It also provides cascade water lines with their water rights, and it prevents fish from moving upstream to get to the dam where they cannot make paths. So all of our 411 CFS goes through our 6 intake gates, which are right here. This is our intake channel. This channel is designed so it settles out some of that suspended sediment in this channel. Our juvenile fish screen is right here. We've had H&H out here quite a few times doing some ADCP work to get our velocity through that juvenile fish screen to 0.4 feet a second to meet our biop requirements. And then an additional 51 CFS goes out past our juvenile bypass that allows the juveniles that do make it into this intake channel to return back to the downstream river below the barrier. 60 CFS that goes through that juvenile fish screen ends up in this back channel here. It flows over a series of chimney weirs. The majority of it goes down below to by the entrance gates, which is about 280 CFS, give or take, which we use to attract fish into the facility. The rest goes, depending on tailwater elevations, the rest goes up to the top. We have two gates here that feed pool 10, which are right by our fish retention devices. And then the rest go out and feed each individual pre-sort pool where we hold those fish overnight. We can control the head differential out into the tailwater to attract fish. We changed that by species, time of the year, the makeup of where the channels are in the river, the thowag, and temperature. So we change that quite often. We actually put ADCPs on each one of those gates this year for our fish study, so that we could track velocities coming in and out of those gates at different settings. So that's the general makeup there of how water kind of flows through the facility. I'm going to go over some of the improvements we've made. This is the back side of the crowder. So early on when we first started, we had a large fish mortality event. Fish were jumping into the ASLs and asphyxiating themselves overnight. So we ended up putting this bar stock on the back side of the crowder, and that's what holds them from getting to the ASLs overnight from day-to-day operations. So we've accomplished that. This was the very first sediment management system we put on the crowders. You can kind of see the bar stock's not on there yet. And this was to remobilize the sediment into the water column so that we could actually crowd forward to the ASLs. This is one of the second iterations. It was air as well, but we had to increase the size of the line to actually effectively mobilize the amount of sediment we get in each one of those pre-sort pools. Trying to go through these pretty quick so I can get to some of the questions if you guys have any here at the end. We did try a sediment mixer. They use these a lot in wastewater applications. It worked really well, but ended up cavitating quite a lot, and we were wearing them out within a couple weeks. Fish retention is another big one. We've had problems. Nate kind of spoke to it earlier. They were these V-traps right here. Fish were not only swimming back out the V-trap portion of it, but there was actually a 8-inch gap on the bottom. So we made this longer one in hopes that the rake on the actual V would prevent them from button hooking out of the facility. We then added this, which proved very unuseful. That's another picture of it before adding the little extension piece on there. And this is where we're currently at. We developed a finger weir in-house, kind of drew a little sketch, sent it over to Portland District, and then we've made several iterations. A lot of the flow-on finger weirs, as you guys probably know, go through little veins in the actual head portion of that finger weir. We actually put a UHMW sheet on top of it, which increased attraction into it quite well. And then this little piece back here prevents fish from flopping back up and over. And this is adjustable by height, and we can fold it up for our crowders to put their flat panel down in the pre-sort pool. This is kind of the very first version of the finger weir. You can kind of see it's the typical design where fish would swim over these veins here. We did add on our fish ladder, some of the weirs in that ice harbor design were at the wrong elevations and tilted, so we had to cut off all the tops, and then we added UHMW weir tops to those, which not only help with abrasion for the fish, but seem to control flow more uniformly across those weir tops. We tried this fish retention device this past year. It's a pass-through design. These are crab pot fingers. Worked really, really well for steelhead. Not very many other species liked it that much. So we will be incorporating a dual design this next year of a finger weir and this pass-through design on the bottom of it. We did have to add brushes around the entire foot crowder length due to gap tolerances around the edges here to prevent fish injuries. Same thing with this rubber around the ASL shroud, just to prevent this ASL as it turns, it creates some sort of scraping hazard to fish. Juvenile fish screen, since we do get a lot of sediment, organics in the water, we had to develop a air system to keep that juvenile fish screen clean so that we could get proper flow through the entire facility the whole time. It operates off a 2-inch air pipe controlled on a solenoid via our PLC system. And that's kind of what it looks like when it goes off. It cleans each individual panel all the way down this 84-foot long juvenile fish screen. And see reference at how long that is. We added this pipe so that Muckleshoot Indian tribe could get their fish to their tank, which could be transported over to the hatchery that's right next door to our facility. This is their MIT holding tank. This is where they hold their brood stock. Why we're sampling Chinook. We added this little UHMW piece here to help fish slide down that Brell section because this was kind of perforated steel and fish would get stuck on the length of this here. Here's a false weir to kind of attract them into the opening to get into their truck. We added this rubber flaps on here to prevent them from going in when they're not supposed to. And you can kind of see the pass through on the left there and one of the finger weirs on the right hand side. We had to add this jumping deterrent for steelhead. It was just right here at concrete. We ended up with 2 steelhead mortalities in this area when we first missioned the facility. This is the amount of sediment that used to get behind the juvenile fish screen. There's some mud valves here that we now operate on a regular. This is in front of the juvenile fish screen sediment. And you can kind of see this is the 4-bay, those 6 gates right there, the intake gates that I spoke about earlier. And I'm going to go ahead and leave the last 3 minutes for any questions.
All right, great. Thank you guys so much. There are a lot of questions. I think let's maybe start at the bottom. I think maybe most of these have been answered. There's a price tag question. Do we know the price of the facility? They've been to the Minto facility in Oregon and it was estimated at 35 million. So what do you guys have?
It was originally put out to bid, I think, for 133 million. That included all 3 phases with Cascade Water Alliance improvements. We got some subsequent money. We're close to probably 180 to 200 million right now.
Good. Trying to find ones that Kevin hasn't answered. Is there an air burst on a timer or manually operated? Also, what about the pressure?
So the airburst system on the juvenile fish screen is automatically controlled via head differential between the front side and the back side of the screen, or every 20 minutes. The pressure on that is around 50 to 75 psi, depending on if it's fall or regular season.
Yeah. All right. I feel like Kevin answered many of these. Kevin, if you're on and able to maybe, is there anything that you haven't been able to answer that these guys maybe should in the next minute here? You can maybe drop it in the chat.
I see the power requirements of the ASL. So that's the only hydraulic operated power unit we have on the entire facility. And each one of those is about 15 horsepower each. Just scrolling up on some of these questions. Kevin did. Operation and maintenance. Oh, go ahead.
Yeah. No, go ahead. You found one. Go ahead. This will be the last
operation and
one.
maintenance needed for the Obermeyer weirs. So every year we're supposed to tighten some of the bolts on the bottom of the bladder / retention device for each one of those. And then we got to drain the air system quarterly, stuff like that. Make sure there's no moisture, and then your standard maintenance for any air compressor. A lot of our maintenance around the barrier in general involves concrete repair. We have a lot of erosion on the actual concrete itself with all the bed load and sediment we move throughout the facility.
All right. I think we're gonna have to end there. We are at our hour. Nate, Casey, thank you guys so much. This is a very cool project. It's huge as well. So congratulations on your work for making a successful project, getting those fish moving. Appreciate you speaking with us today and sharing your knowledge and experience. And Kevin, thanks on the back end for answering some questions since we were engaged with the presentation for so long. Thanks everybody for attending, and we hope to see everybody again in February. Take care.